Okay, in section 3.6 here, we're going to talk about polynomial and rational inequalities. Now remember from talking about it before, inequalities means that something is not necessarily equal to. So we're talking about greater than and less than, or greater than and equal to, or less than or equal to. So we're talking about these symbols. There's your greater than, less than, greater than or equal to, less than or equal to. Those are the symbols that we're talking about here. Excuse me, sorry. Because we're talking about polynomial and rational inequalities, we're not talking about a linear one variable function. But in order to kind of remind us, we're going to go back to what that idea was. So let's say we had something very simple. We have a number line, 0 in the middle, and I simply want to have the inequality that x has to be greater than 0. Well, if x is greater than 0, if we look on our graph, we would simply put an open circle at 0, and because we want all of our x values to be greater than 0, well, now let's think about this. If I were to put a 2 in the place of x, that would give me the statement 2 is greater than 0. Is that a true statement? Well, 2 definitely is greater than 0, so that is a true statement. If I was to put 1 in the place of x, 1 is greater than 0, that is a true statement. What if I was to put a negative 4 in the place of x? Well, negative 4 is not greater than 0. That is a false statement, so that is not true. So if I was going to plot all of the possible points, well, I've only picked whole numbers here, 1 and 2, and all of those points work. Everything also in between there works, because what if I was to say 0.01? Well, 0.01 is greater than 0, so that's true. So you have to take into account all the points. That's why when we did this, we would kind of shade this line right here all the way out here, and then we would put an arrow just indicating that this thing goes on forever. Okay, it's going to keep on going well past the end of the white line that I had. So what I did was I basically shaded the area of the graph that made my statement true, that x is greater than 0. Okay, that's the general concept. Now what if we did one that looks like this? Maybe I've got, maybe this is -2 and maybe this is 4. And I want you to tell me where x is in between -2 and 4. And let's include -2 and 4 this time. So we're going to say that -2 is less than or equal to x, which is less than or equal to 4. Well, obviously, what we did before was we would put a solid dot on the -2 because it is included in my inequality. We would put a solid dot on the 4 because it's also included in my equality, and the x literally, physically lies in between those the way we have it written. So we would shade all of this area here, and that would be my answer. And then one more, and then we'll actually get to our examples for polynomials and rational functions. So let's say that instead of being in between -2 and 4, I want x to be less than -2, or I want x to be greater than or equal to +4. Now, there is no way that both of those things can happen at the same time. I cannot have a number which is less than -2 that's also bigger than 4. There's no overlap there. That doesn't make any sense, because if I pick -3, well, that's definitely not bigger than -4. But what it says is I only need to have one or the other be true. So I still have to show all of the region that both of those things are true. So if I want x to be less than -2, that means it's got to be an open circle. And then less than -2 would go to the left from -2. So we would shade that region, and we would put an arrow because that one will go on forever, because anything less than -2 is going to make that part of the statement true. How about if I want x to be greater than 4, greater than or equal to 4, excuse me. That means we put a closed dot on 4, and I'm going to move to the right for as far as I can go and put an arrow on there. Something like that. Not the best looking arrow ever, but there, you get the idea. So I could have a region where I've got multiple solution sets, multiple answers, and they're separated, and that's also a possibility. So now we're going to try and take a look at how this all fits in with polynomial and rational inequalities.